Okay, we're going to talk today about more about domain and range. This is not a specific page in the note packet, but just some added questions that I wanted to show you to help you answer the questions in the Delta Math tonight. So when we look at determining the domain on which a function is either increasing or decreasing. So in this case, we're talking about decreasing. So when we're looking for decreasing, going left to right, if we look at this graph, we can see that I'm starting here and I'm increasing until I reach this maximum point here. Then I start decreasing. So when they're asking for when it's decreasing, you need to find the place where it hits the highest point and then until it reaches the lowest point. It does not include the highest point because at that point, I can't really say if it's increasing or decreasing. It's just kind of the highest that it gets. It's not increasing nor decreasing. And the same thing with the ground. It's no longer increasing or decreasing. It's just hitting the ground here, if you think of this as the ground. So when is it decreasing is always going to use in parentheses because we're talking about not including those endpoints. When does the decreasing happen? Well, the decreasing, if you think of that, those are the y values. Y values are going up, then the y values are going down. So it's not using the y values. Whenever you're doing this, you're always going to be talking about the domain, the x values. So if I follow that domain down, I can see that it starts decreasing at an x value of 5, and it stops at the x value of 11. So the domain for when it's decreasing is starting at 5 using a parenthesis, comma 11 using a parenthesis. So starting at 5 and decreasing until 11. Let's try another one. So again, we're looking for the domain for when it is increasing. So talking about increasing, if we look at the function, we can see that it's starting to increase. We have an arrow here. That means that it's starting at actually all the way left, so going to negative infinity. And it's going to be going up, 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 up until it hits that x value of -5. Then we can see it'll start decreasing from this point onward. So we're only talking about the purple part for when it is increasing. So it starts at the negative infinity and it continues increasing until -5. And again, those endpoints are never included when we're talking about increasing or decreasing. Okay, this next question talks about, again, they're telling you in here, we're talking about the domain for which the f of x, remember f of x is a fancy way of saying y equals. So we're looking for when the y values are negative. So when I look at the graph, I'm looking for the y values to be, if they're negative, that means below the x-axis. So when does that happen? So when are the y values negative? I highlighted it in purple. It starts at negative infinity and it stops at the -5. And we're using parentheses because, again, at that -5, it's not really negative, it's at that 0. And that's neither positive nor negative. And then it starts again at 3 and continues until infinity. And on the Delta Math, if you're going to choose to use the interval notation, you're going to want to make sure that you say it's either that one or, so you're going to use that U shape on the Delta Math. You could also say that it's when x is less than -5 or when x is greater than 3. That's an equivalent representation. You could use inequalities because it doesn't specifically say the intervals need to be used. And then one more example, determine when this is the f of x, so again, y values are positive. So that is when the y values are above the x-axis. So I've highlighted that in purple, and since it's starting with the arrow that's negative infinity and it continues until 3, and then again we're going to want to use that or, and then it starts at 7 and it continues to infinity. So hopefully these help you to be able to answer some of those questions on the Delta Math, and we'll go through more of these in class. Have a good night.